What you're about to explore takes you behind the scenes of how a U.S. Navy aircraft carrier transforms into a full-scale flying base in minutes. You'll see how hidden workshops below the deck prepare aircraft, how the flight deck executes synchronized launches and recoveries, and how cutting-edge systems and human expertise keep everything moving seamlessly. By the end, you'll understand why this process matters more than ever, and how every elevator ride and deck crew movement plays a critical role. Beneath the flight deck of a modern aircraft carrier lies a world of relentless motion, unseen by the public but vital to everything that happens above. The hangar bay, spanning roughly 200 meters in length, 30 meters in width, and about 8 meters in height, acts as the carrier's logistical and maintenance core. Here, dozens of aircraft are stored, serviced, and prepared for flight, surrounded by an intricate web of cranes, trolleys, and specialized workshops. Every operation in this space is timed down to the second. Technicians rotate between stations, performing checks on engines, hydraulics, electronics, and control surfaces. Fuel crews handle aviation-grade fuel systems under strict safety standards, while maintenance specialists work in close quarters to ensure each jet remains flight-ready. The space is divided by large fire-resistant curtains, creating 3 major compartments that can be sealed in emergencies or for separate maintenance tasks. At the center of it all is the hangar control section, known as the V3 division. This is the nerve center for all below-deck movement, coordinating towing, fueling, equipment transport, and elevator operation. Each aircraft has its precise parking spot, assigned based on size, fuel load, and readiness level. The coordination required here is extraordinary. Crews often work 12-hour shifts to maintain constant operational flow. Elevators are the true lifeline of this system. Each can lift over 70 tons, moving aircraft and gear to the flight deck in under 30 seconds. Newer carriers now use electromagnetic or all-electric systems, replacing hydraulic lifts. These upgrades cut downtime, reduce maintenance costs, and improve energy efficiency, all while keeping the rhythm of operations smooth. Every movement inside the hangar directly impacts the flight deck's tempo. If an aircraft isn't refueled or serviced below, it can't launch above. That's why the hangar isn't just storage. It's a synchronized machine of human skill and technology. When the call for launch comes, every screw tightened, every tire replaced, and every checklist completed down here ensures the deck above runs with flawless precision. Each launch is a masterpiece of engineering and timing. The aircraft taxis to the catapult under guidance, wings extended and engines roaring. Steam or electromagnetic energy powers the catapult, accelerating the jet from 0 to 300 kilometers per hour in just under 3 seconds. Within moments of liftoff, another aircraft rolls into position. Meanwhile, arresting gear crews stand ready for landings, deploying steel cables capable of stopping returning aircraft in less than 120 meters. Efficiency is everything. Deck crews rehearse continuously to minimize time between launch and recovery cycles. A single cycle involves up to 20 aircraft, with launches and recoveries often overlapping in a seamless pattern. The speed of this ballet determines how many missions or training flights can occur in a day. A delay of even 1 minute per launch can translate into hours of lost operational time. Safety remains at the heart of everything. Strict adherence to procedure keeps both crew and aircraft secure. Training covers deck awareness, spatial positioning, and emergency response drills under different conditions: daylight, nighttime, or rough seas. Every hand signal, every step, and every refueling motion has been practiced thousands of times. This deck ballet represents the pinnacle of human coordination. It's a living demonstration of trust, discipline, and communication, where every movement supports the next. As the operation cycles continuously, launch, recovery, reset, the flight deck becomes a visual symphony of timing and skill. In the next section, we'll see how new technologies are elevating these complex systems to unprecedented precision. While precision and timing define today's operations, the future of carrier aviation lies in the fusion of human expertise with cutting-edge automation. Every new generation of carriers builds upon decades of innovation, integrating advanced materials, electric systems, and intelligent software that redefine what ready means. Modern carriers now feature all-electric aircraft elevators designed for smoother, quieter, and faster movement between decks. These systems eliminate hydraulic fluid risks, cut maintenance demands, and use smart sensors to monitor load balance and speed in real time. The result is not just efficiency, it's predictability. An aircraft can be raised or lowered at exact intervals without manual adjustment, ensuring a seamless transition between hangar and flight deck. Automation doesn't replace people, it amplifies their ability. Crews now use digital interfaces that track every aircraft's position, fuel state, and maintenance history. Predictive analytics systems identify potential mechanical issues before they occur, preventing downtime and increasing safety. Instead of reacting to problems, teams anticipate them, maintaining an uninterrupted rhythm of operations. Training has evolved, too. Crew members now train with high-fidelity simulators that replicate deck conditions, weather changes, and equipment malfunctions. These virtual environments prepare personnel for real-life conditions, minimizing errors during live operations. Collaboration between departments, engineering, logistics, aviation, and maintenance, is constantly refined through daily synchronization meetings and automated reporting tools. Emerging technologies are transforming even the most traditional aspects of carrier work. Electromagnetic launch systems, EMALs, have replaced steam catapults, reducing stress on aircraft and enabling finer control of acceleration. Advanced arresting gear systems are now computer-regulated, automatically adjusting cable tension for different aircraft weights. The combination of these innovations allows faster launch rates with less wear and tear. Yet, the essence of carrier operations remains human. Every upgrade, every system, still depends on disciplined coordination. People remain at the core, making split-second decisions, adjusting equipment manually when needed, and maintaining focus through long hours of precision-driven work. The broader implication is clear. Carriers are no longer just floating airfields. They're integrated ecosystems of data, engineering, and people. Future designs are expected to include hybrid power systems, autonomous support vehicles, and AI-assisted flight sequencing. These advancements will not replace the human element. They'll empower it. As the evolution continues, what we witness is a masterpiece of engineering shaped by collaboration. It's a reminder that innovation doesn't only come from machines. It comes from the humans who keep them running in harmony. When you picture a carrier, don't just imagine the jets soaring into the sky. Imagine the countless people below making it possible. The hangar bay, the flight deck, and the teams connecting them form one living, breathing system of precision. Every lift, every hand signal, every takeoff is part of a larger rhythm that defines excellence. What you've seen isn't just coordination, it's creation in motion, proof that when humans and machines work together perfectly, even steel can dance.